Module 5, Joint Probability and Sampling Theory. Now, what do you mean by joint probability distribution? The study of two random variables x and y together is known as joint probability, which defines the simultaneous behavior of the two random variables x and y. And the joint probability of the two random variables can be given as P. The x value lies between two values, and similarly along with that the y value also lies between two values. As compared to the random variable of only x, the study of two random variables simultaneously is called as joint probability. The joint probability distribution of two random variables is also known as bivariate probability distribution. The joint probability distribution of two discrete random variables is usually written as P of x is equal to small x, comma y capital Y is equal to small y. And some of the properties of joint probability distribution or the mass function of the discrete random variables x and y is f of xy should be greater than 0, summation of x and y together taken should be equal to 1, and f of xy is defined for two random variables x comma y. Joint probability is the study of two random variables simultaneously, whereas marginal probability distribution is the individual study of or the individual probability distribution of a random variable, where the values of the variable x and the values of the variable y will be separated. If x and y are discrete random variables with joint probability mass function f of x comma y, then the marginal probability mass functions of x and y will be given as an individual parameter, that is f of x is equal to p of capital X is equal to small x, that's equal to sum of f of x comma y. Similarly, f of y is equal to p of capital Y is equal to small y, that's equal to summation f of xy of the y values. Above is a description of the joint probability distribution table, wherein the horizontal, the row indicates the y values and the column indicates the x values. This is the joint probability distribution table. If the marginal distribution table is asked, then the y value should be separated and the x value should be separated. Note that the last column is a row column. This f of x1 is obtained from the sum of this value, that is h of x1 y1 plus h of x1 comma y2 plus so on. F of x1 is the sum of all these values. Similarly, f of x2 is the sum of all these values. Likewise, g of y1 is the sum of these values. So, when you write the marginal distribution of x, we need to consider the x values, the column wise, and the last row f of x1, f of x2, f of xn. And the marginal distribution of y will be the horizontal values of y and the column values of g of y1, g of y2 and so on. And some of the properties of the joint probability distribution is the expectation. And a mean value of the probability distribution of a variate x is commonly known as expectation of the variable x and denoted by E of x. Similarly, for the variable y, it is given as E of y. And that will be equal to summation y f of xy. F of y. The expectation of the joint probability is given by E of g of x comma y, where it is taken as summation I, summation j g of xi comma yj pij. And the covariance is given by expectation xy minus mu x mu y, where mu x is the mean of the variable x and mu y is the mean of the variable y. Correlation of x and y is given by covariance x comma y upon sigma x sigma y, where sigma x and sigma y are the standard deviation of x and y respectively. And if two random variables x and y are said to be independent if expectation of xy is equal to the independent expectation of the variable x into the independent expectation of the variable y. That is, e of xy should be equal to e of x into e of y for all values of x and y. And the covariance of x comma y is equal to 0. Consider an example. Find the marginal distribution of f of x and g of y for the following table. The marginal distribution is obtained by forming the row sum and the column sum. So the above values are given. As discussed earlier, the row sum. This half has been obtained by 1 by 8 plus 1 by 4 plus 1 by 8 gives you 1 by 2. Similarly, 1 by 4 plus 1 by 8 plus 1 by 8 gives you 1 by 2. And the column sum is obtained by adding the vertical values. That is, 1 by 8 plus 1 by 4 gives you 3 by 8. Similarly, 1 by 4 plus 1 by 8 gives you 3 by 8. And 1 by 8 plus 1 by 4 gives you 1 by 4. Note that the sum, the column sum and the row sum should not exceed 1. You can see that 3 by 8 plus 3 by 8 plus 1 by 4 is equal to 1. And also 1 by 2 plus 1 by 2 is equal to 1. So any problem given, the row sum and the column sum should be always equal to 1. As discussed earlier, the marginal distribution of the joint probability distribution means the individual behavior of the variable x and y. As again, from the table, the x values are 1 by 1 and 5 and the row values is half and half. That is, f of x is half and half. Similarly, the y values will be the horizontal values of the joint probability distribution, that is minus 4, 2, 7, and the column sum which you have got it at the end, that will be the g of y value. Consider one more example where we have to find the marginal distribution of the variable x and y and also find the covariance. The table is given as below. Now to form the marginal distribution, we have to first find the row sum and the column sum. Now you can see here 1 by 6 plus 1 by 6 plus 1 by 6 gives you 1 by 2. 1 by 12, 1 by 12 plus 1 by 12 gives you 1 by 4. Similarly, 1 by 12 plus 1 by 12 plus 1 by 12 gives you 1 by 4. And the column sum 1 by 6 plus 1 by 12 plus 1 by 12 gives you 1 by 3. 1 by 6 plus 1 by 12 plus 1 by 12 gives you 1 by 3. And 1 by 6 plus 1 by 12 plus 1 by 12 gives you 1 by 3. Note that the row sum and the column sum together will be equal to 1 because 1 by 2 plus 1 by 4 plus 1 by 4 is 1. Similarly, 1 by 3 plus 1 by 3 plus 1 by 3 is 1. Now for the marginal distribution of x and y separately, for the x values, consider the vertical value below x given as 2, 5, 7, and for the f of x value, consider the row sum, that is 1 by 2, 1 by 4, 1 by 4. And for the y values, consider the horizontal values given in the joint probability distribution table, that is 3, 4, 5, and for g of y value, consider the column sum, that is 1 by 3, 1 by 3, 1 by 3. Now this gives the marginal distribution of x and y. Now to find the covariance, we have seen that covariance is given by expectation of xy minus mu x mu y. First find out mu x, that's given by summation x f of x. So from the marginal distribution table of x, consider 2 into half plus 5 into 1 by 4 plus 7 into 1 by 4 gives you 4. Similarly, mu y is obtained from the marginal distribution of the y table, which gives 3 into 1 by 3 plus 4 into 1 by 3 plus 5 into 1 by 3 gives you 4. Now the expectation of E of xy is equal to xy h of x comma y. For this, we have to go to the joint probability distribution given in the example. There, consider the first x value, that is 2, first y value, that is 3, into the first value of the table, that is 1 by 6, plus x value, the second y value, plus the second value of the table. Similarly, 2, 5 into 1 by 6, plus 5 into 3 into 1 by 12, plus 5 into 4 into 1 by 12, and so on with all the values gives you 16. So, the covariance is given by expectation of E of xy minus mu x mu y, that's equal to 16 minus of 4 into 4 is equal to 0. So, this is the value of the covariance.